Welcome to the 24 Hours of PASS. This is the Summit Preview Edition for 2016. We're very excited to have with us today Andy Yoon, who will be giving his session on performance pitfalls of code reuse. The 24 Hours of PASS event consists of 24 consecutive live webinars delivered by expert speakers of the PASS community. These sessions will be recorded and can be found later on at www.24hoursofpass.com for all the sessions. My name is John Geerder. I will be stepping through a few introductory slides before I hand over the reins to Andy. Next slide, Andy. Soon I got a frog in my throat there for a second. All right, so if you require technical assistance, please type your questions in the questions pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask questions throughout the presentations, and then we will, at the end of the presentation, Andy will go through and answer your questions for you. You are able to zoom in and out of the presentation by using the zoom button, and then at the end of the presentation, if you can fill out the short evaluation for us so that we can improve based off of your feedback. We really appreciate having those for us. Next slide, Andy. We do want to thank our sponsors, Microsoft, Idera, Attunity, I said that correctly, Hewlett-Packard Enterprise, and SQL Sentry to helping us support the 24 Hours of PASS. Without their generous support, we would not be able to do this free of charge. So we want to thank them. Next slide, Andy. We do invite you to explore SQLPass.org. PASS is a not-for-profit organization which offers year-round learning, such as the 24 Hours of PASS, webinars, online local or online virtual chapters, SQL Saturday events. So it is good to join PASS. Next slide, Andy. And then finally, don't forget about PASS Summit. That's coming up at the end of October, I believe the 25th to the 28th. There'll be over 200 sessions from world-class data experts such as Andy that will have a lot of good presentations. You can save $200 off your registration by using the discount code 24HOP200 if you register before September 18th. Next slide. So finally, I do want to introduce you to Andy. He is a SQL Server DBA and developer, been working with SQL Server since 2001, and is the chapter leader of the Chicago Suburban User Group. I've actually met him at several SQL Saturday events, and he is a pretty awesome presenter. So with that being said, here is Andy.
Thank you very much, John, and thank you everyone for joining me tonight for 24 Hours of PASS, Performance Pitfalls of Code Reuse. Super excited to be here. So without further ado, let's cut to the chase and dive right on in. So I want all of you to pretend for a moment that you are the SQL Server subject matter expert at your company. Your company is a managed services company such that you manage a wide variety of different databases for a number of different either clients and or other business groups and business units. And throughout all those different databases that you happen to manage, some of them you're very intimately familiar with, and others you're not so much so. You either haven't worked on them very much, other application teams have worked on them, etc., etc. So for the last 2 weeks, you've been on vacation on this beautiful beach. And even better than being on this beach, you were completely off the grid. No cell phone, no internet, nothing. No one from work bothered you. Isn't that a dream for a DBA? So it's now Monday morning. You've just returned to the office after your fantastic couple of weeks off. You haven't even cracked open your email yet. You're just enjoying some coffee when unfortunately the peace and quiet is interrupted. So look everyone, it's your coworker Max. So Max runs into your office. He slams the door and he's freaking out right now. Max says, hey, I need your help. Now, Max is a guy that you worked with for quite a while. He's on the business side of things. He's a finance whiz. He's an Excel whiz. And on occasion, you've been teaching him some basic T-SQL so that he can kind of write some reports and do other things that he needs to do without pestering you as much. And he's a smart guy. So he's in your office freaking out on this Monday morning saying, hey, you got to help me. You know, Sadie, she's barking up a storm right now. She's going to bite my head off. Okay, whoa, hold on for a second, Max. What's going on? Slow down. Explain to me, why is Sadie angry with you, or what's going on right now? So Max goes on to explain to you that last week while you were out, Sadie had gone to Max and said, hey, we're going to be audited. One of our major systems has these auditors breathing down my neck, and we need to have some report data ready for them by Monday morning. All right, Max, well, what report data? What do we need? So Max goes on to explain that the audit is for the automobile dealership system that you guys manage. You think to yourself, okay, that's not a system that you really know very well because it's not one that you developed and you really work on very much. But as Max explains these report requirements to you, you kind of think to yourself, okay, that's not too bad. You know, you could probably figure out the T-SQL in order to develop this or whatnot. So as Max finishes explaining all this to you, you say, okay, you know, this report makes sense. So, well, Max, what did you do? What happened? And then Max goes on to explain to you that last week, because you're out and he doesn't have the T-SQL skills to get the data for this report, instead he had to turn to someone else. He turned to the person who developed the automobile dealership system, Byron the Beaver. So Byron is an application architect. He happens to know some database stuff and some SQL Server, you know, enough to be dangerous. But otherwise, his specialization is as an application developer, and he's quite good at it. And long ago, a couple of years back, he actually developed a proof of concept system that was the automobile dealership system. But as proof of concepts go, that proof of concept kind of became and morphed into production. So anyway, Byron's all, Max tells you that Byron's all excited that he says, yeah, absolutely, I'll help you out. You know, I built that system from the ground up, and you know what? I think I remember I have these awesome code objects in this system. So yeah, so we can reuse some of that, and I can help you come up with that report. So let's take a quick flashback into last week, and now we're going to see things through the eyes of Byron and go through what Byron showed to Max to help him out. So we're going to jump into Management Studio now. All right. So we're going to be using the auto dealership demo because we are not working in production, right? You don't test in production, right? So here are all the different questions that we have to answer for our report requirement, right? How many vehicles did each salesperson sell? Well, Byron's like, hey, I have a view for that. VW salesperson sales per month. Let's take a quick look at that output. So we see some salespeople here, the number of sales per month, blah, 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 blah. Fantastic. Here's the thing, though. We have to show annualized data. We don't want monthly data. That wasn't the requirement. Well, that's fine. We can modify that view and write an annualized query. So Byron says, you know, we're going to use the year function. We're going to do a quick sum of sales. We're going to do a quick group by. I run this quick bit of code, and you can see here, oh, hey, you know, I've ordered by, you know, first name, last name, so that we can see everything grouped up. We see sales for some of these salespeople over the course of each different year. Fantastic. We've answered one of our questions. And then Byron says, you know what? That's really useful. So I'm going to wrap that up into a quick view and add that to the system so that we could reuse that later. So we've just created a view salesperson annual num of sales. Okay, next question. How much profit did each salesperson net for the dealership? Well, we have a view that shows all inventory sold. We also have a UDF to calculate net profit based upon the VIN. UDF calc net profit and VW all sold inventory. So by combining the two of those, you see now that we can get back a list of VINs, their vehicle invoice prices, what they actually sold for, and the actual net profit, when they actually sold for, and the surrogate key ID for the sales history table. Fantastic. We've just answered one of the other questions. So the next question is, how much commission did we pay out to each salesperson? Well, commission rate is shown on the salesperson table. So we're going to query base view salesperson. And we see first name, last name, and a commission rate value. Wait a second, why are we doing this base view salesperson? Isn't the table called salesperson? And Byron points out, well, you know what? Every single table in this system that I developed has to have a corresponding view on top of it. Why? Because of abstraction and security. So no one should ever query a table, only a view, and those are his rules. So here's a quick query to show you that, querying sysobjects. So you see here's all the different actual tables within our automobile dealership system, and here's the corresponding base views. So per Byron's rules, all queries must go off and be based upon these base views. All right, fine. So let's bring all of this together into one nice, simple query. It's a moderately lengthy query, but you know, we're using a sum of UDF calc net profit to get our dealer net profit. We're going to use a case statement here to determine, depending on what the net profit value is, whether, you know, how much commission a salesperson gets. And Byron even makes a note that, hey, we should wrap this into a UDF later because we may use this calculation later. And then we're going to be querying against a couple of different views. We're going to be querying against all sold inventory, the view that we created earlier, view salesperson annual number of sales. We also have to get a few data points from a couple of the other tables that these views don't have, so we have to join against base view sales history and base view salesperson. We're going to run it with a couple of test parameters, year sold 2016 and last name Gilbert. And voila, we have our data. We have exactly what Sadie is looking for. That's fantastic. So, you know, Byron tells Max that, hey, Max, you know, you're good to go here. But you know what? I'm going to make life easier for you since, you know, that big chunk of code is really daunting. So I'm going to wrap all this up into yet another view for you to use. So we're going to create VW salesperson annual profit. Run all that. So now the final report query that you have to just wrap a nice report around is simply this. You know, so hey, Max, doesn't this look pretty simple? You know, select a handful of columns from VW salesperson annual profit. Let's run this test. And as we saw a moment ago, when we ran the unviewed version or the expanded version, we get our data back. Fantastic. So what's the problem? Well, here's the thing. Sadie is greedy. Sadie doesn't want to run that report that Max wound up whipping together late last week using that particular query for every single year and every single of the, 200-300 salespeople that are in the system. She doesn't want to run that each and every time. Instead, she wants to see all the data. So this is what Sadie is actually doing right now. And Sadie's sitting here, and sitting here, and sitting here, and getting angrier and angrier and angrier. I'm actually going to stop this query because I already know that this will not finish in a timely fashion. All right, so let's return back to the present. So Max has, you know, finished telling the story of exactly what happened, and you say, okay, Max, you know what? We can help you out here. No problem. But before we do so, you know what? I want to back up for a second and just explain to you some of the reasons why Byron's approach may not have been the best one. You're hiding in my office. It's okay. You know, Sadie's not going to be around here, so we got a few minutes, so you can calm down and you'll be all right. So let's talk about why each of us does what we do. Let's explore Byron's perspective first. So Byron, the application architect, was raised on the DRY principle of do not repeat yourself principle. And if you think about it, in many regards, you know, not repeating yourself, not repeating chunks of code makes sense in many regards. If I write a chunk of code here and I copy it to 8 other places because I need to use that functionality in 8 other places, if I later have to come back and fix a defect, I have to make sure that I do that, you know, propagate that same change in 8 other places. That's a lot of work. Why not encapsulate it and then just call that function, that routine, from all those 8 different places? Therefore, there's only one copy of the code. And in many regards, it makes sense. The thing is, a lot of that mentality, if you will, has its roots in how people like Byron were raised, if you will, or trained, if you will, how they cut their teeth in the development world. What do I mean? Well, let's take a step back into the realm of computer science. If you're a computer science major, some of this will be familiar to you. But for the most part, and I'm speaking generally, application developers are trained as developers via procedural programming languages. And this class of languages, which is a form of imperative programming, the lines of code, the code statements define the machine state. I want you to do exactly this, this, and this. And the machine will do exactly as the code dictates. And then, as these languages evolved over time, they were very oh, I'm at a loss for words all of a sudden. They were very prone to being encapsulated into structures and subroutines and grouped together, if you will. And then the object-oriented methodology further extended that with classes and all sorts of crazy things like that. So if you look at the common languages I listed below, a lot of these languages are languages that we're familiar with. But there's a language here that's missing that we're working with right now. And that's because it is not a procedural programming language. T-SQL is a declarative language, and it runs by completely different rules. So in this particular case, code statements describe the desired result, and code dictates logical flow, but not the actual control flow of what we should really be doing. I like this particular slide here because this is a great way to kind of summarize the differences between procedural/imperative and declarative. The first defines how to do something, whereas declarative defines what you would like to happen. I want to explore this a little bit further using a nice real-world example. So we have a nice recipe here to create a simple pasta dinner. You have to go prepare your sauce. We're going to make some sauce from scratch, so you have to go to your fridge, you get some vegetables, you prepare that, you go to the pantry to get some additional ingredients, prepare that. Eventually you have to go to the fridge again to get some ground beef. You have to prepare that, brown that, combine it all, add your tomato sauce, let that simmer, and eventually you also have to go back to your cabinet. You get your water, your stock pot, you fill that with water, you get that boiling, you cook your pasta, you combine it all, and eventually you come up with a nice pasta dinner if you follow this recipe. So if we were procedural, we can't necessarily look at that code, that recipe, and change things up. We have to follow it exactly. So I must go to the fridge first to get my first set of ingredients. Then I must go to the cabinet to get my first set of tools. And then I must go, do some work. Then I return to the fridge later to get my ground beef. I then return back to the cabinet to get some other tools that I need. Eventually I have to go back to the fridge again for something else. And then eventually I'll go to the sink, and et cetera, et cetera, et cetera. I have no room to adjust or decide that I want to do this or this instead. It's just this is how it is. The code dictates exactly what I must do. On the other hand, if we were declarative, I might decide, you know what? Even though I look at this entire thing, it would be more efficient for me to go to the fridge and get everything that I need all at once. It would be more efficient for me to go to the cabinet and get all of my tools and dry goods all at once. And then I'm going to say, you know what? I know that it takes a while for my stove to boil water, so I'm going to get my water boiling first, and then I'm going to start working on my sauce. I've rearranged the steps, but in the end, I will still have the same pasta dinner as a result. So what about SQL Server? Well, SQL Server's input is code, T-SQL code, like this particular query. And the result is an execution plan. And this execution plan has a number of different physical operators. Your index seek, your sort operation, your merge join, your nested loop. So how does SQL Server get from code to execution plan? Well, it goes through and uses the Query Optimizer. So what follows now is going to be a brief, high-level, deep dive into the Query Optimizer and what the Query Optimizer does. There are people out there who do entire sessions and entire day-long sessions about the Query Optimizer. I have about 4 minutes to cover the Query Optimizer. So again, I'm going to gloss over a lot of things, but This will give you a brief glimpse into what SQL Server is really doing when it's dealing with your query. So the input is a T-SQL statement. The first phase is called parsing. And fundamentally what it's really doing is checking its syntax. Is this a valid T-SQL statement? The second step is binding. Fundamentally what's happening here is that all the different objects that are being referenced in your T-SQL statement, your table names, your columns and whatnot, they're all being bound to the actual tables objects within your database. So we're tying them together, tying the metadata together. Another thing that happens during binding is that if, for example, you're querying a view, those views are expanded. So it's not that your view code happens to be executed first, it's all executed all at once, all as one big thing. So all of your view code has to be expanded. The output of the parsing and the binding phase is a logical tree of operations. I'll cover more about that in a minute. And then we enter the optimization phase, which I'll cover more in the next slide. The output of the optimization phase is your execution plan. And once your execution plan has been set, has been chosen, it is set in stone. You go execute that. There's no, oh, I'm starting to execute this. Oh, maybe I should change something on the fly. Once your execution plan has been selected, that's your plan, for better or for worse. So let's explore optimization a little bit more. Like I said, the input tree, the logical input tree, is the result of the parsing and binding phase. And what that simply kind of shows you, again, from a simplistic perspective, it's a tree that shows, for example, I know I need to get data from table A, and I need to join it to table B. I need to do this operation and that operation, but they're logical operations. The tree doesn't, the input tree doesn't say, for example, that I'm going to be doing a index seek on this particular table or a scan on this particular table. It's just I need to get data from this table. So that's what we're starting with. Simplification. A number of really awesome, crazy things happen during simplification to try and pare that input tree down. The simplest example that I like to give is the algebra principle of if you have three tables, A is equal to B, B is equal to C. So therefore, A is equal to C. So if you have a query such that you only need records out of A and C, you can actually eliminate the join to B because A and C are effectively equal to one another. You've just simplified by removing one of the tables that you coded in and needed to query, but really you actually don't. Derive cardinality. So at this point, SQL Server will then collect all the different statistics information for all the different objects that it's going to go after. It's not going to do anything with this information just yet, but it's got to collect all of it. And this is where it's going to, get information to make use of, or to come up with things like your estimated row, estimated number of rows for different operators and things of that nature. But like I said, we have to collect all that cardinality information first. Next, we have a trivial plan. Is this T-SQL statement so simple that we can just come up with a trivial plan and call it a day? That's pretty boring. If the answer is yes, we short circuit, we come up with a trivial execution plan and we go off and execute it. Now, exploration. Now, this is where the magic and the fun really happens. So SQL Server has a more optimized logical input tree that has cardinality associated with it and whatnot. So what SQL Server does now is that it starts in parallel trying to come up with a number of different execution plan permutations by using different physical operators. Now it's trying to figure out, will an index seek against this table be cheaper or faster than, or more or less expensive than, say, an index scan, or using this index instead of that, or should I just do a full table scan? Should I do a nested loop join here? Should I do a merge join, et cetera, et cetera? It starts making all these decisions really, really fast and working with these different plan permutations. And eventually, it'll come up with an execution plan for you. It'll select one, the lowest cost one, and then that's what it'll run with. But here's the thing. It's not going to come up with the best possible plan for you. That's actually kind of a misconception. The goal of the Query Optimizer is to generate a good enough plan quickly. Good enough and quickly. Well, with quickly, the thing about the Query Optimizer is that it only has a limited amount of time in order to do all this exploration. And once it runs out of time, if it hasn't finished all the different permutations, it'll just say, oh, I'm out of time, I'm timing out. You happen to be the lowest cost, I'm running with you. There's your plan. SQL Server will always generate an execution plan that will always get your data back for you. Some of those plans may take longer than others, but again, the optimizer only has a limited amount of time, and it has the same amount of time no matter the size of the T-SQL query that you hand it. So if you hand it something simple, it has the same time slice versus something gigantic. Operator cost estimation, when it's actually looking at the different costs of these execution plans, it's looking at each different operator. It comes up with an estimated cost value, and then it sums it all up. And as you see here, that cost estimation takes into account a number of different factors. But the one I'd like to focus on is cardinality, row estimations. So let's take a closer look at the second and the third points in the context of our pasta dinner analogy. So I want all of you to kind of take a quick look at at this recipe here. Pretend that this is your query, if you will, and it's up to you now to be the query optimizer, and you have to come up with your own plan that you think will be able to get, help or allow you to create this pasta dinner in a efficient fashion, in a nice, fast way. What did you come up with? Well, you didn't have very much time, so you probably timed out on that one because this is a lot of work to do, a lot of decisions to make in a very small, short time slice. Now, what if instead I give you a much simpler set of instructions? I want you to go prepare the ground beef, which would entail going to get the ground beef from the fridge and then sautéing it and browning it on the stove. Okay, that's much easier. If you're given that same time slice, you can come up with some different with an estimated execution plan. What is your game plan, right? So let's talk a little bit about estimates and cardinality. So one of the steps of your execution plan is to go get that pound of ground beef from the fridge. Well, what if you open that fridge door up and you don't see a pound of ground beef? Instead, you see a steak, which means you have to now grind that steak into ground beef. You have to do extra work because despite what you thought was in the fridge, what you estimated, that was not accurate. So if your estimates and cardinality are off, the execution plan that you come up with can be negatively affected, and you may have to wind up doing more work in the same kind of vein. So I want to just show you this slide again and just allow you to kind of digest these talking points, because these talking points will be revisited, and we'll explore them a little bit further as we now return back to our and go and help our coworker Max fix his problem and deal with that code. So back to the story. All right. So to revisit again, we have the report requirements up here. We had our green CFO wanting to see all the data, so she was just running this query without any parameters, and it was taking forever and a day. So I'm not going to execute that now. Instead, I'm going to look at the estimated execution plan first. So despite the fact that we only have one query in here, the first thing that jumps out at me is that there are two queries that actually show up here. First is the actual base query, but then a second query in here, a second execution plan in here for UDF calc net profit. Well, the percentages, as Max is looking over your shoulder, Max is like, the percentages is only 3%. I don't care about that. Well, hang on there. The execution plan is not telling me the whole truth. Let's explore this a little bit further. So first I'm going to use some extended events. I have two extended events out here, batch start and completed, and statement completed. You can also create these in Profiler if you wish, but this is my first foray into extended events, so I had to give it a shot here. I have the code definitions in the solution, but I don't have the time to show them to you now. Don't worry about it. So we're going to free the proc cache. We're also going to turn on statistics IO and statistics time. We're going to be using those extensively throughout the rest of this presentation to show you what SQL Server is really doing. And then we're going to add in a predicate here just to make sure that this query can actually return back some data to us in a timely fashion. So I'm going to start my two sessions. I'm going to execute this query. Okay. So the first thing I'm going to look at is this. This is the output from setStatistics.io. The number of logical reads represents the number of data pages that were read from each of the different corresponding tables. And we see here if we total these up, it's probably around, just over 6,500 logical reads. But here's the thing. This is one of the cases where Statistics.io is not telling us the whole truth. It's not showing us everything that this query actually did, the amount of work it actually did. For that's why we had to fire up extended events. Let's look at batch start and completed. So in reality, let's zoom in here. This is the completed. This is the number of logical reads. And look at that. We did over 300,000 logical reads. That's a heck of a lot higher than the, 6,000, 7,000 logical reads that I initially thought we did. Heck of a lot more work. Well, why do we do all that additional work? Well, where did this additional work come from? That's why I'm going to show you T-SQL statement completed. So here, what we actually see are 192 individual events here. Let's look at one. So in this particular case, this statement, which actually exists within the UDF, fired 100, not 192 because there's a second statement, but whatever 192 divided by 2 is, about 90-something. It fired 90-something different times. So that's an individual query against the sales history table and the inventory table. And for each of the times that it fired, let's look at the number of logical reads over here. Almost 4,000 logical reads for every single execution. That's almost as much as the entire base query that we saw earlier. And this adds up, and this adds up really, really fast. So as I just showed you, the impact of scalar UDFs are hidden. Let's take a simpler look at a simpler example, one that doesn't have all the views and all that other kind of stuff. So I'm just going to do a simple query against inventory and sales history against UDF and use the UDF CalcNet Profit. And I'm just going to select top 100. I don't even want that many records back. And this simple query takes 4 seconds to run. Here again, Statistics.io shows me about 318 logical reads. If I go back to my batch start and completed, in reality, that top 100 really did almost 400,000 logical reads. A lot more work than that 300-some logical reads. All that was hidden from us, but that was all additional work that SQL Server had to do because I was using that scalar UDF. Let's take a look at the statement completed. I have to scroll about halfway down. Here we go. And again, we have a similar case, similar situation as we saw a little while ago. Each of these individual statements, from a logical read perspective, has to process almost 4,000 data pages every single individual execution. That's the thing about these UDFs. For every single row in my record set, that UDF code will fire once individually. So I did a top 100, so this thing just ran 100 times. If I did it for everything, it's going to run a heck of a lot more. If you have a data set or a query that pulls back millions upon millions of records with some scalar UDFs in it, that code inside is going to run once for every single record. What if that UDF is not just a simple single statement query like this simple example is, but what if it's a bunch of code? That's a heck of a lot more work that you have to do on a row by agonizing row basis. That's awful. We don't like that. So what's the solution? How do we deal with this? Well, taking a quick look inside UDF CalcNet Profit, in this particular case, all we see that we're simply just taking sales history sell price minus inventory invoice price. And that's simply it, and we're just returning that particular value. So in this particular case, really the best solution is to get rid of UDF entirely and just write a situation-specific focused query. So we're going to take our simpler example from earlier, inventory and sales history, and just do sell price minus invoice price. I'm going to run that. Oh, hey, that ran in about 1 second. logical reads here and logical reads here, so about almost 5,000 logical reads. Let's see if it's telling us the truth. Let's look at our event here again, extended event. Yes, it is telling us the truth. That's fantastic. And if we look at the statement completed, if we scroll all the way to the bottom, there's actually no additional entries in here because we didn't run any other statements. This is the only thing that ran. So there was nothing hidden from us. Oh, and by the way, did you guys notice that I didn't even do the top 100 this time around? That ran in 1 second for all the records. That returned back 191,000 191,000 records as opposed to 100 records in 4 seconds. Just we got rid of that UDF just because we didn't have to run that code on an individual row by agonizing row basis. Okay, so let's return back to the original example, and we're going to say, okay, Max, I'm going to create yet another view. I'm just creating views just for simplicity and for consistency's purposes, but we're going to create a different one that's VW salesperson annual profit, no UDF. So you see that the only change I've made is to get rid of the calc net profit UDF, and we just have the direct calculations substituted in here. That's it. So I'm going to run this view query with our test data. Boom, it ran. If you remember before, it took about 4 seconds. In this case, it ran almost instantaneously. That's fantastic. We have a huge improvement here. That's wonderful. But you know what? I see something very strange here about the output of SetStatistics.io. Because here's the thing. We're only looking for first name, last name, year sold, dealer profit, commission, annual sales. So why, pray tell, are we looking at these tables? And while we may not be doing very much work against them in this particular case, I still want to know, why are we querying these particular tables? We're not getting any columns out of here. So let's explore this a little bit further. All right. So what we're going to do is we're going to take a look at the definition of VW salesperson annual profit, no UDF. And in this case, we're just going to look at what are the different tables that we're querying. In this case, we're looking at VW all sold inventory, base sales history, salesperson, and then the view that we created earlier, that Byron created earlier, VW salesperson annual number of sales. So we need to dissect each of the other two views and see whether they have any references to those other mystery tables to find out what's going on here. So let's first take a look again at VW salesperson annual number of sales. That one references VW salesperson sales per month. So we have to go to the definition of that. Scroll down a little bit and we see that that particular view goes after base view salesperson and base view sales history. All right, fine. Our make, model, color, the vehicle attribute tables are not in here. Let's go against VW all sold inventory. Okay, now we're getting somewhere. We see that we have a reference to VW vehicle base model and VW vehicle package detail. Let's take a closer look to VW package detail. We see that goes against the inventory, VW vehicle base model again, and base view package. Well, all right, now we have two different references that are going against VW vehicle base model. So if we look at the definition of that, now we finally have found the references to make, model, and color. So why does this matter? Well, you remember earlier when we were talking about the query optimizer, even though this is the simple query that we see, all views get expanded. So if I display the estimated execution plan for this apparently simple query, it's actually a really large, complex execution plan that's going against a number of different objects. Why? Because we have nested views going on in here. So there's a lot of different things going on in here. And remember how we were talking with the query optimizer, if you give it a larger problem in the same time slice, it's going to be more challenging to come up with an optimal execution plan. Now, unraveling all that was kind of a pain, having to go through each of those different pieces of code. So I've actually come up with a free community tool called SP Help Expand View, and I want to show that off to you guys right now. So in this particular case, SP Help Expand View, it takes a couple of different parameters. We're going to pass in the view name, and we're going to choose one of the different output formats. In this case, we're going to show a horizontal output format. This is the format that I like to use for quick glance analysis. So if I run that, what I see is that from left to right, I can just scroll and I see the relationships and I see the number of different levels, the nesting levels that this particular view actually has. U in this particular case, by the way, stands for user table. So I can see, for example, from this base object here, there's reference to base view sales history, which then goes down to sales history. All sold inventory happens to reference, vehicle model, vehicle, package detail, et cetera, et cetera. So we see how, vehicle-based model gets queried here on level 5, and it also gets referenced here on level 4. And it gets hit a number of different times. So this is really nice because it dynamically will give you as many columns as possible. Now, if you want to do some processing against not only just with single view, but a bunch of different views, say against an entire database's worth of views, you can use the vertical format. The vertical output format now uses a parent-child object hierarchy IDs, so you can do some parent-child type queries and whatnot. So that way you can kind of get a better idea of the different relationships, and you can dump all this output into a table and work some of your own analytical magic against it. Additionally, there's another optional parameter in here called show object count. While it can't show you the number of times that a given object was referenced entirely throughout the nested view, it can show you the number of times an object was referenced as far as the number of levels it was referenced in. So if you have a nested view that goes down 7 levels, and a given object may have been referenced in 3 of those levels, that will show you, that's the value that will show up in show object count. So if I run that and I look at my second result set, I see that the sales history table came up in 3 different levels. Salesperson came up twice. We saw that vehicle-based model and the vehicle tables showed up in 2 different levels. So this is a really cool, handy tool that I'm pretty proud of. I developed it last year, and I want to share that all with you. It's free. It's available out there. You can just Google that. But so why do we care? Why do we care about all this nested view stuff? Well, one of the reasons that I'd like to show you in the next demo script, it has to do with cardinality and the query optimizer, some of the stuff that we talked about earlier. So let's explore that a little bit more. So we're going to use set statistics IO and time again. I'm going to use a different view called cardinality inventory sales history all. Let's do the horizontal output just to give you a quick glimpse of it. Okay, so scrolling quickly to the right, I see that this particular nested view goes 7 levels deep. I see that there seems to be some kind of repetition going on here at first glance. So if I scroll a little bit further over here, I see base inventory detail, base view inventory detail shows up a couple of times from the inventory sales history view that gets referenced. And that gets referenced twice redundantly because of this particular view is joined against this particular view. So again, this is a nice quick way to try and dissect and at quick glance see what's going on in here, why these references are showing up. If I look at the object count output, I see that my inventory table is being hit at 4 different levels of the 7 levels. That's quite a bit. Sales history is being hit twice, and so on and so forth. Okay, so we're going to turn on actual execution plan, and then I'm just going to run this particular query, actual execution plan, and then we're going to go look at some details about this. Okay, first I want to go look at the output of both set statistics time and set statistics IO. First thing I want to show you, because it's the first time I've run this query, or because I also flushed the proc cache earlier, we actually see the parsing and the compile time that this particular query took. So we can actually see now how much time it took for SQL Server to come up with this execution plan, and we see that it took almost 2 seconds. That's quite a bit of time, actually, as far as parse and compile goes. Let's also record the actual execution times from SQL Server side. If we take a quick eyeball glance at the amount of I/O, the amount of work it did about 10, 12, 15. I'll say almost about 19,000 logical reads. Okay. We also take a closer look at the number of rows. In this particular case, this query came back with 47,000 rows. Remember that number. Because now we're going to look at the execution plan. And we're going to look at some of the different properties. Now, most of the time, people, when they look at different properties, they'll just hover over an operator and look at the pop-up, right? But here's the thing. If you open up the properties pane, and I'm going to lock it here, the properties pane actually shows you a wide variety of other awesome information. So let's doing that. I'm going to look at the select operator, which is kind of like a summary, if you will. First, let's zoom in and look at, oh my goodness, estimated number of rows. Wow, that is definitely nowhere close to 47,000. That's pretty obscene. The thing is, as you nest further, the optimizer has a much more challenging time with its cardinality estimations. And as a result, cardinality estimations go way out in left field, as you see right here. Estimated subtree cost is about 85,000 or 8,500. The memory grant here, I'd like to point out that's the amount of memory that this query will need to complete. That particular value is a relatively high 265,000 kilobytes. We see the optimization level here is full. And in this particular case, we did not see a timeout. That should show up in a later example. So, on the other hand, if noting some of those different things, let's look at the same equivalent query that is just a focus-specific query. So no views whatsoever. It's just one single flat query. And let's compare and contrast, okay? So first, if I look at the parse and compile times of this particular statement, oh hey, that is a heck of a lot smaller by a factor of 10. And let's look at the actual elapsed time. Oh hey, that's 1/3 the time. That's pretty awesome. And let's look at the number of logical reads. Just by eyeballing this, we did a heck of a lot less logical reads too. We did a lot less work. This is awesome. This is fantastic. All for the same 47,000 records. Nothing else changed. Let's look at the properties real fast. Zoom in. Estimated number of rows, 22,000 for a total of 47,000. So not spot on, but a heck of a lot more accurate than the, 1.1 billion that we had earlier. Estimated subtree cost is only 18 as opposed to 8,500. We see down here that reason for early termination of statement actually shows up here. We actually timed out in this particular statement. But despite the fact that we timed out and just went with the best plan that we happen to have, that best plan still happened to be awesome compared to the prior plan. We still had a huge improvement. Oh yeah, look at the memory grant value here. Only 55,000 kilobytes required as opposed to the 250-something thousand that was required in the prior. So this is really awesome. Now here's the thing. Why do we care? Now remember that this particular query is just running alone on its own. But if I had more time, I would spin up a workload and show you the two queries side by side as they run with a concurrent system workload. And what you would see is that the flattened query runs far more efficiently than the nested view query because, again, when it's competing for other resources as opposed to having an entire server to itself, things like memory grant really come into play as it's competing for RAM and other things of that nature. All right. So let's return back to the original base query that we were working with. I'm going to create another view called Salesperson Annual Profit Flattened. I'm only doing that for the purposes of demo and for simplicity of reading for the purposes of this demo. But in this particular case, we've removed all view references. We've completely flattened this, and we've already removed the UDF references. Okay? So we're going to run let's see, I'm going to turn on actual execution plan. We're going to run the no UDF query as a baseline, and then we're going to run the flatten query thereafter. And then we're going to take a look at the differences just like we did a moment ago. All right. Now in this case, the first query, the one with no UDF but still with nested views, took over a second to parse and compile. If I scroll further down, oh hey, a fraction of that time for the flattened query to parse and compile. That's a huge improvement. That's awesome. Whatever that percentage works out to be, that's how much of a percentage savings you just took. That's phenomenal. That's a huge amount. Let's look at the actual execution time, 1.5 seconds, and because of parallelized, it used the CPU for 2.5 seconds. Oh hey, the flattened version, just cut that. What is it? Yeah, cut that in half. That's really awesome. Do you want to go tell your boss or your colleagues that just by flattening some code out, you were able to increase its performance and its execution time by 50%? That's pretty cool. I would say so. Let's take a quick look at I/O. Well, I see this particular case. There's a case where we're doing over 400 or almost 400,000 logical reads. I can already tell from eyeballing here that I'm nowhere close to 400,000 logical reads. I do a heck of a lot less work with a more focused, flattened query. Now let's take a look at some of the differences on the execution side and the properties pane. So by the way, the results of each query, they threw out 1,180 records each. So taking a look at estimated number of rows of the first query, almost 600,000. That's nowhere close. Our estimated subtree cost was 168 units. In this particular case, we had a timeout for trying to come up with a plan for the no UDF with nested view query. Let's look at the other one in comparison. Estimated subtree cost, 17. Estimated number of rows, better, but not optimal, but still better. Full optimization. And the memory grant value was also lower too. I forgot to show that from the prior one. So this is 61,000 memory grant up here. 113,000. Fantastic. That's a heck of an improvement. So by flattening this query and by, oh yeah, by the way, did you notice that I wasn't doing a top anything? I pulled back all that data within a second. So now we've just saved Max's bacon. We've helped him out, and Sadie can have her numbers, and we can complete the audit. So yay, we saved the day. So here's a handful of parting thoughts and some kind of lessons learned, if you will. But the thing that I really want to impart on everyone as we kind of, look over these parting thoughts is that just about everything that we do in SQL Server is a trade-off. So if you choose to go one path, you're going to suffer different kinds of consequences. If you go choose a different path, you're going to suffer some other different kinds of consequences. And in my experience, code reuse methodologies, while they have their place, usually scale very poorly as an application gets larger, as your data volume increases, as your workload increases. And as a result, if you're going to go that one, down the path of code reuse, be smart about it and understand that in the future you may be ripping all that out because your application, your workload has increased to such a point that that code cannot handle it anymore because it was not able to scale. Because of the way SQL Server is, because it's declarative, T-SQL is declarative, you just have to work within the confines of it is what it is. So take advantage of it as opposed to trying to fight it. So with that, I just have a quick little resources page. Don't worry about copying all this stuff down. The slides are already available all online, but here's a bunch of different awesome resources on a number of different topics that I covered. And with that, are there any questions?
I don't believe we have any questions out there.
Okay then. Then I did either a really, really great job or you all fell asleep.
According to this, we had 70% activity.
Fantastic. So then, Well, you just want to give it a minute, see if anyone is typing in any questions?
We got one question here.
Okay.
From Dale, we got two. Oh, Andre, Andre just said he's still awake.
Yay!
David asks, I've written views to remove data complexity from the report writers at my company. I note that the views do not run much slower than the flatter code. But how do I provide a reasonable base of code for that group?
That's a very good question. Now here's the thing. I mean, if you have views that are maybe just one, maybe two levels deep, you're probably going to be fine. You're not going to see the same kind of performance drop-off. But the thing is, as you continue to nest views, that's where you start really taking your performance hit. So if you only want one or two levels worth of views, I don't care. That's totally fine. You're not going to see these kinds of consequences. But it's a slippery slope. So if your application folks start using views on views on views, that's when you're going to start seeing those consequences. But if, again, it's absolutely reasonable to have a single layer of views to, again, abstract for your report writers and whatnot. A flattened view is, is perfectly fine.
All right. Mohammed just says, great job, Andy.
Oh, well, thank you very much.
And is there any other questions out there?
Going once, going twice?
I feel your force. Function, great job. We'll use your function. When will your function be available?
It already is. I actually published it about a year ago, so if you go to my blog, in the upper left corner there's a link directly to all the different blog posts I wrote about it, and the code itself is up on GitHub. And if you do try it out, please send me your feedback. If if it works great for you, or if there's features you would like to see, let me know. Or if you want to, take a branch on GitHub and contribute, and I'd be happy to credit you and appreciate the help if you want to help improve it. That's why it's up on GitHub.
All right. Great store procedure, thumbs up. That was from Eric.
Thank you.
Dylan says, hi Andy, great talk. As views are broken up to increase performance, what's the best practice to maintain them?
Honestly, the best practice to maintain them is really just to bite the bullet. Use some code tools if you possibly can, source control and things of that nature. But honestly, writing more focused queries, the trade-off is that you're going to have more developer maintenance and developer overhead. But hopefully the positive trade-off is better application performance. So would you rather be called into the principal's office because performance in the application sucks, or would you rather spend a little bit more time on the development side of things to offer a better optimized code such that you don't get bothered once that code gets rolled out into production for performance issues?
All right. Any other questions? I think that was it.
All right, fantastic. In that case, next slide.
You go ahead and do that one if you like.
Okay, so coming up next, we have Eduardo Castro. He's going to be presenting on R for the SQL Server DBA. So hope you guys enjoyed this session. Thank you again for joining me tonight. And let's continue having some fun now with 24 hours have passed. Thank you all again.
Thank you.